left physics video. Piro made a video to half a day. It's total incomprehensible jibber jabber about waves and fields, and so I thought I would say something on the subject of waves. Try to be generic, and I'm not an expert on whatever these would be, but whatever. There's a science for this stuff. It's not earth science, but there's a science for the forces involved in molecular transmission of molecular transmission. And so I'm going to try to put it in terms that are how I understand it anyway, and simplifications, let's just call them. But let's understand that. Okay, I'm theorizing that essentially electrons are tied together by a kind of a spring, ping pong ball action kind of a thing. And that's tying protons to protons, and it's also tying atoms to atoms. It's a lot weaker, but it's there. Okay, the atoms are compressed by the field gravity, generally speaking, and there's a fight back. They have a thing between them that creates a little bit of a compressed rubber band or something. You can think of it as a spring. Everything's just kind of sprung, and everything's kind of compressed into a position, comfort. And so when you have a wave in water, for example, the water has an even tension. Everything's kind of quiet, everybody's happy, and let's say something falls into the water and creates a disturbance. Well, the disturbance is a bunch of compression down this way. Okay, so a lot of stuff is getting compressed down, and it's going to spring back, and it springs back. Can't spring back where the thing is because that's heavy. So it ends up leaking this way. So the energy of the spring back leaks in another direction, maybe even directly perpendicular by theory. But regardless, it springs back, and what happens is the water attempts to defy gravity. Okay, it springs out. It's shooting water in this direction. So it's a vector out in the opposite force in the general direction opposite. Okay, it has a vector. It has a component of energy in the proper direction. It has some in the wrong direction, but some in the get this back, the equal but opposite reaction. And so that's the beginning of your wave. And what essentially happens is, because it didn't come out straight up, it now has an obligation, in a sense, okay, to keep moving forward and forward. And it's doing that by a kind of rotation, probably. It's these molecules are bound to each other, and what it starts, gravity is pushing it down, and so they're just going to start rotating those arrows through the wave. So it's just kind of a rotation of that force. So it's this spring, and in this spring, the springing back has also compressed this water. So this water's been compressed the opposite direction. So it fights back this way, and then that gets compressed and it fights back this way, and then that gets compressed and it fights back this way. So it's really the water pushing and pulling against its own mechanism, and that's the vibration. So all the springs start vibrating, and they're vibrating in a general direction. And I think it is kind of got a little bit of a circle to it, so that's probably what creates what you call your undertow, is the fact that it is sort of ends up rotating this force. Just because of the way gravity is pushing down in a straight manner, and it just keeps turning everything into a circle, so to speak. It rounds off the edge, takes the edge off of this rolling wave. And so that's how a wave moves, is it's a bunch of springs compressing. Okay, something impacts, the two springs now are close and very hard, high compression. Okay, and then the springs expand again. Okay, low compression. And that's what's happening. That's what happens when sound travels through the air, is the molecules are kind of in a happy position next to each other, and then that position, that little bit of force is compressed. When sound hits and something moves this way, let's say, and it compresses this thing, then this one compresses the one next to it, and this one compresses the next one to it. So it's just a compression wave, a wave of force between the binding energy between the molecules is getting compressed. Not the molecules per se, but the energy between them is compressing. And it's a ping pong ball thing. The ping pong ball is bouncing this way, nice and happy, bouncing this way, More force, that means more, it has to move, and it moves, and then that forces the ping pong balls in the next segment to go really close together. So it's just really a migration of a compression. Now, you know, they're going to apply this wave concept to something like a photon in a field, and they're going to have a field that has, somehow it has two components, this magnetic thing and this electrical thing, and somehow it's moving in both of these fields somehow. But you know, what kind of mechanism do you need? That this is a very complex mechanism created by protons, electrons inside of all these atoms, and you know, it's a rather sophisticated spring. And so you're going to take this field and create this thing that's created by complex matter being in arrangements with each other, you know, molecules being in specific locations, specific magnetic bonds, and you're just going to have this as some sort of generic function of the universe, and then you're going to sit there and take something and push it through it just to, you know, bing, and somehow you're going to control the decompression of all these springs, and they're not going to go this way or all kinds of different ways and spread out, like, which is normal, but somehow it's all going to go in some kind of straight line through this synthetic matrix you're creating, when the simple answer is the photon is a thing and it moves from one place to another in a straight line. It goes there. Why not the simple answer? Why do we need to create a whole complex infrastructure for it to travel through, just like gravity? Why do we need bent space when we can have the easy answer, which is a bunch of photons are coming down and they're pushing us, they're hitting us? Yeah, a simple answer. Why not the simple answer? Why go for this complex one? So anyway, this whole idea that this wave thing means something is, you know, it doesn't. You know, that this is somehow a significant function of compression and decompression. And the frequency is basically going to be based on the elements that are compressing. You know, whether you're compressing inside of an atom or whether you're compressing outside the atom will decide this kind of a frequency thing. You know, and obviously the force of the initial spring, of course. But that's all there is. You know, it's not terribly complicated, and it certainly is force that's migrating. Yes, the atoms might not be migrating. I mean, the atoms themselves don't have to go move very far to do their bit. Their little individual part in the play doesn't require them to move very far, because the force does it. The springs do it, and you just keep, you know, almost in a. It loses strength because you can see that this is rather complicated. There's a lot of movement here. Compress a spring, relax a spring. Compress a spring, relax a spring. And you're going to have some losses to the environment, and the wave is going to weaken over distance because of those losses. So yeah, I guess I don't need to say more than that. I'm just saying, you know, this is a complex function of a medium, of an arrangement between specifically designed atoms that have specific bonds to each other and adhesion to each other. And you know, that's why something like a bucket of sand, you're not going to be able to get much sand. You're not going to get any waves to travel through it, because there's nothing tying them together. There's no force between them that's at all interesting. So there's nothing to compress, and so there's nothing to rebound. Alright, but yeah, probably just keep it simple. So I'll just add this to the wave particle videos and attempt to appropriately title it as just a how do you make this material medium of trapped force that's compressed applicable to some kind of invisible matrix in the universe that has these compressible springs? What are you going to make them out of? Come on. And when you have the simple alternative of screw all that, yeah, let's just have real tons do it. Okay, enough said.